Hey guys, today we're going to continue with our optimization lesson. This is slide 5, which is on the third page, the first example on the top. So here we're maximizing area. It says a rectangle is bounded by the x and y axis, and the graph of y equals 3 minus 1/2 x. What dimensions of the rectangle would produce a maximum area? So since this is the x-axis, and this is the y-axis, I'm going to call the base of the rectangle x and the height of the rectangle y. And then they tell you that it's bounded also by this line here, which is y is equal to 3 minus 1/2 x. So we're trying to find the dimensions that would produce a maximum area. So the area of any rectangle is xy. So this is what I want to maximize. Now in this question, we're also given this point here, which is the location of, or rather the height of the rectangle which intersects the line. So that is y is equal to 3 minus 1/2 x. Since I have what y is defined to be, I can then plug in y into my area equation so that everything is in terms of x. So my area is going to equal to x times y, which is 3 minus 1/2 x. Since this is what I want to maximize, we're going to distribute and then take the derivative to find the maximum. So this is going to equal to 3x minus 1/2 x squared. If I find the derivative, that's going to equal to 3 minus x. And when we're finding the derivative, we make it equal to 0 so that we can get those critical numbers, which if you were to solve this, you would subtract the 3, divide by -1, so you get that the critical number here is x is equal to 3. So now what we're going to do is we're going to verify that this is indeed a maximum. Let's say if I were to plug in 2. If I do 3 minus 2, I get a positive. And if I plug in 4, 3 minus 4 is a negative. So this is indeed a maximum. So now that we have this critical number, this maximum, x is equal to 3, that is our first dimension. So now I just need to solve for y. Since we have the equation for y here, I can take my x and plug it in. So y is equal to 3 minus 1/2 times the x, which is 3. This is going to give me 3 minus 3 over 2, which then I would have to put this over 2, so then multiply the numerator by 2, and that gives me 6 over 2 minus 3 over 2, which is equal to 3 over 2. So my dimensions, since now I have x and y, are 3, which is the x, by 3 over 2, which is the y. And since we weren't given any units, we don't have to worry about any units. Let's go to the next question. We have here the point, determine the point on the line y equals 2x plus 3, so that the distance between the line and the point 1, 2 is a minimum. So here what we're trying to minimize is distance. Now, as a reminder, I put here what the distance formula is. D is equal to the square root of x1 minus x2 squared plus y1 minus 2 squared. So we have one point, and you can assign this to be either x1, y1 or x2, y2, that doesn't matter. And then the other point is the point on the line that would give us a minimum distance. So that's what we're trying to solve for. We're trying to solve for the point on this line, so the other coordinate, that would give me a minimum distance. So what we can do here is we're trying to minimize distance, and I'm going to plug in this point into my distance formula. Now I am choosing to assign 1, 2 as x2 and y2, just because I like x minus 1 versus 1 minus x. So we would have here x minus 1 squared plus y minus 2 squared. Now this is obviously not enough for me to try to minimize, but we are given that the line is y equals 2x plus 3. And since we're trying to find the coordinate on the line, that means that the y value of the coordinate is defined by this equation. So I can take this y and plug it into my distance. So d is going to equal to the square root of x minus 1 squared plus 2x plus 3 minus 2 squared. Now we're going to want to simplify this and perhaps distribute the exponent so that way we combine like terms and it will be easier to take that derivative. So d is equal to the square root of x minus 1 squared plus, then this is 2x plus 3 minus 2, so 2x plus 1 squared. Let's go ahead and do this. I'm going to do this on the side, the multiplication. So x minus 1 squared is equal to x minus 1 times x minus 1. If I distribute everything, this would give me x squared minus x plus 1, which is equal to x squared minus 2x plus 1. So far, I have that d is equal to the square root of x squared minus 2x plus 1. And now I'm going to do the same thing with the 2x plus 1 squared. So 2x plus 1 squared is equal to 2x plus 1 times 2x plus 1. When I distribute, that would give me 4x squared plus 2x plus 2x plus 1, which can then be simplified to 4x squared plus 4x plus 1. So I'm going to add that here. And now we're going to combine like terms. So we have x squared plus 4x squared, which is 5x squared. Then negative 2x plus 4x is plus 2x plus 2. Now since I'm going to take this derivative, I'm going to rewrite this with the rational exponent. So that would be 5x squared plus 2x plus 2 raised to the 1/2. The derivative of this, we would have to use the chain rule. So we bring the 1/2 to the front times 5x squared plus 2x plus 2 raised to the negative 1/2 times the derivative of the inside, which is 10x plus 2. Now let's rewrite this so it's a little bit easier to work with. This is going to give me 10x plus 2 over the 2 from the 1/2. And then this is all down in the denominator because of the negative exponent, and it is a square root of 5x squared plus 2x plus 2. Now when we're finding these critical numbers, since this is a rational function, remember that your critical numbers is both when the numerator is equal to 0 and when the denominator is equal to 0. Now, if I set the numerator equal to 0, I would have to subtract the 2 and then divide by 10, which can then be simplified to negative 1 over 5. Now if I try to set the denominator equal to 0, 1, we would not be able to factor this quadratic. 2, if you use a quadratic formula, you would end up with a negative inside of the square root. And if that, if you want to be sure about that, what I do is that I find the discriminant of the quadratic, which is the b squared minus 4ac. This is what goes inside of the square root when you use the quadratic formula. And if you end up with a negative, that means that there would be no solution because it would be an imaginary unit. So if I do that, b squared is 4 minus 4 times 5 times c. And you can see that this is 4 minus 40, which gives me a negative number inside of the square root if I were to use the quadratic formula. So the denominator is never going to equal to 0, making negative 1 over 5 my only critical number. So we're going to verify that this is indeed a minimum. A number less than negative 1 over 5 would be, let's say, negative 1. Negative 1 in the numerator would make the numerator negative. And then if I plug it in the denominator, negative 1 squared would become positive. So 5 minus 2 plus 2 would still be positive. So a negative divided by a positive is negative. And if, let's say, I plug in 0, I would get positive over positive. So this is indeed a minimum. So I have my x value, but now I need the y value. And since we have this equation, we can just plug in the y. So y is equal, plug in the x, to 2 times negative 1 over 5 plus 3, which is going to equal to negative 2 over 5 plus 3 over 5. 3, which I have to put over 5, so I'm going to multiply this by 5. So this is negative 2 over 5 plus 15 over 5, which is equal to 13 over 5. So I have the x, I have the y, so the point that would give me a minimum distance would be negative 1 over 5, comma, 13 over 5. Moving along. Here we have a rectangle ABCD with sides parallel to the coordinate axis is inscribed in the region enclosed by the graph y is equal to negative 4x squared plus 4, as shown in the figure below. Find the x and y coordinates of the point C so that the area of the rectangle is a maximum. So first of all, we're trying to maximize this area. Now, if you look at this picture, right, we have the base of the rectangle is right in the middle of the axis here. That means that this here is the positive x and this here is a negative x. But in terms of distance, that would be the absolute value of this negative x, since distance is always positive. So for the base of this rectangle, we would call that 2x, since we have this x plus this x value. So now, and then the height would be the y. So A, the area, is going to equal to 2xy, and this is what I want to maximize. Now we have here that this point is bounded by this graph, which is y is equal to negative 4x squared plus 4. Since I have y defined, I can plug that into area, and that way everything would be in terms of x. Therefore, area is going to equal to 2x times negative 4x squared plus 4. Distribute the the 2x, and that would give us negative 8x to the third plus 8x. And that's your area. So now I need to find that derivative so that I can get my critical numbers. And this derivative is negative 24x squared plus 8. Make it equal to 0. First, we would subtract the 8. So negative 24x squared is going to equal to negative 8. Divide negative 24. We get that x squared is equal to 1 over 3 when you simplify. And then when you square root, we get that x is equal to plus or minus 1 over the square root of 3, since the square root of 1 over 3 is the same thing as saying the square root of 1 over the square root of 3. Now, I have your plus or minus. However, we're trying to find the coordinates for C, and C is on the positive x-axis. Therefore, my actual critical number that I'm concerned about is the positive 1 over square root of 3. So we're going to make sure that this is indeed a maximum. Now 1 over the square root of 3 is some fraction. So when I come here to my derivative, I'm going to plug in 0, and that would give me 0 plus 8, so positive. And if I plug in 1, which is greater than this fraction, that would give me negative 24 plus 8, which is a negative. So this is indeed a maximum. So now I'm ready to find the y value, since I already have my x. So y is equal to negative 4 x squared, 1 over the square root of 3 squared, plus 4. And remember that I got this from this equation that I have written. So let's apply the exponent. We get negative 4 times 1 over 3 plus 4, which gives me negative 4 over 3 plus 4. I have to put this over 3, so I have to multiply this by 3. And that gives me negative 4 over 3 plus 12 over 3, which is equal to 8 over 3. So my coordinates for point C is going to equal to 1 over the square root of 3, comma, 8 over 3. Now let's look at a sample multiple choice question. We have here, consider all lines in the xy plane that pass through both the origin and a point xy on the graph of y equals x squared minus x plus 16 on the interval 1 to 8. The figure on the left shows one such line, and the graph of y is equal to x squared minus x plus 16. Which of the following statements is true? So we have this figure here, we have this line, and we have the y equals. Now, if you look at all of your multiple choice options, they all start off the same, the line with a minimum slope, the line with a minimum slope, etc. Okay, so that means that we are trying to minimize slope of the line, which the line here, that's we just know, the only thing that we know about this line is that it goes through the origin. So how do we find slope? Slope is y2 minus y1 over x2 minus x1. Since we know that it goes through the origin, I can plug in 0, 0 into one of these points. So I would say y minus 0 over x minus 0, which is y over x. Now this is what I'm trying to minimize. Now this question gives me what y is equal to. So what I can do is I can take what this y is and plug it in for y here. So we would have then x squared minus x plus 16 over x. I can simplify this because since I do want to find the derivative so I can get that critical number, we're going to have to take that derivative. So this is equivalent to x squared over x, which is x, minus x over x, which is 1, plus 16 over x, which is 16x to the negative 1. So now when I take the derivative, that will give me 1 minus 16x to the negative 2, which is equal to 1 minus 16 over x squared. And we're going to make that equal to 0 and solve for x. So we can subtract the 1 first, and we get negative 16 over x squared is equal to negative 1. Multiply the x squared to both sides to remove it from the denominator. So negative 16 is equal to negative x squared. We can cancel out the negatives by dividing by negative 1, making it both positive. And then we can square root both sides, and that gives me that x is equal to plus or minus 4. Now, if you look at the graph here, we can see that this is on the positive x-axis, so the only critical number that we are concerned about is x is equal to 4. Now we're just going to verify that this is indeed a minimum. So I have 4, and my derivative here was it's this situation, so I'm just going to write it over here, which is the 1 minus 16 over x squared. So let's say if I were to plug in 2. That would be 1 minus 16 over 4, which is 1 minus 4, so we get a negative. And if I plug in 5, I would get 1 minus 16 over 25, which is a fraction, which is less than 1. So 1 minus something less than 1 would give me a positive. So this is indeed a minimum. So here I'd look for where it goes. Here you have all your x values, and the one that we got was 4. So the correct answer is B. And that's optimization.